All right, so today we're going to be looking at Unit 4, Notes number 6. And our goal today is I will be able to apply, there we go, apply linear functions to real world scenarios. And guys, we've already done something very, very similar to this. We've actually done this a few times where we're basically doing the same thing. So if you're like, I feel like we've done this before, it's because we've done some stuff that's extremely similar to it. So it will feel like we've done a lot of this before, which is a good thing. Okay, so look at our first one. This is a problem I actually copied and pasted from our notes way back in Unit 1. So this is something we've definitely done before. So it says Charles is saving $5 each week. He earns an extra $5 by mowing his neighbor's lawn. How many weeks will he need to save in order to have exactly $75? So remember, we knew that this was our question, how many weeks? So that's when we let x equal the number of weeks. Okay, because that's what we were looking for, was the number of weeks. So our equation, it was $5 per week, so 5x. He earns a $15, an extra $15, so plus 15. And we want to know when he'll have exactly 75. Okay, so that was what we did way back in Unit 1. We would solve for x from here to find out how many weeks it took. Okay, so if we think about this, we really have some pieces of information that match our linear functions. The first thing we have is what was our starting point? Okay, our starting point, okay, was the $15. Okay, he started with $15 he got whenever he was mowing his neighbor's yard. Okay, so we're going to say our starting point was the $15. Okay, remember our starting point for linear functions is always our b value. Okay, it's our y-intercept. We started with a 15. If I were to graph it, we would start with a $15 on the y-axis. And then, how is our total changing? Well, it's changing by $5 per each week, saving $5 each week. Okay, so it's $5 per week. Okay, that's how it's changing. Remember, how our linear functions change is by the slope. So that's our m. Our slope is the 5. Okay, so we have our slope and our y-intercept here. Okay, and that's all we need to write a linear function. Okay, so what would the equation have looked like if we weren't given Charles's goal of $75? What if I didn't give that to you? What if it was an open-ended goal? He could earn as much money as he could save. Okay, well, if that's the case, then instead of $75, we're going to use a y. So our y is equal to 5x plus 15. Okay, so now he can he can save as much money as he wants, not just 75. Okay, so these are what we're going to be setting up today. So, for example, number 1 says a department store offers a frequent buyer's card to earn rewards for purchases customers make at the store. Each transaction is worth 12 points, and the customer automatically earns 25 points when they sign up. Write an equation for the situation and be sure to define your variables. Okay, so we have two variables. Okay, so we're going to let x equal and let y equal. Forgot the t. There you go. Let x equal and let y equal. Okay, our y is always going to be our total. Okay, whatever we're adding up, whatever we're looking for, our total of something. Sometimes it's total money. Here, we're going to be talking about the total points. Okay. And the x is always what changes or what impacts our total points. Well, what is impacting our total points? The transactions. So we're going to let x equal the number of transactions. Okay, so now we're going to write an equation to go with this. Okay, so let's think about our b and our slope. Okay, the customer automatically earns 25 points. So that means they're starting with 25 points. That's going to be our B value. And each transaction is worth 12 points. Okay, well, we said X was the number of transactions. That means the 12 and the X are going to go together. And that makes our 12 our slope, our M. So we're going to have Y is equal to our total points equals 12X, $12 per transaction, or $12 points per transaction, plus the 25 points they started with. So that's going to be our linear equation to go with this system. Or not system, a situation. Wow. Alrighty. Looking at number 2. It says your new job is at a custom tee shop where t-shirts are printed to order. For each order, custom tee shop charges $10 per shirt plus a one-time setup fee of $15. Write an equation in slope-intercept form to model the situation and be sure to define your variables. So we're going to let x equal and let y equal. We're talking about money here, okay? And we're talking about an order. So that means our y is going to be the total cost. Okay. And then we're talking about what is affecting the total cost. Well, that's going to be the number of shirts. So now we're going to write our equation. We need to think about what's going to be our M and which one's going to be our B. Okay, well, it's a one-time setup fee. Okay, you have to do your setup fee first of $15. So that's my starting point. And this is $10 per shirt, or $10 per X, because we said X was the number of shirts. Okay, so that 10 is going to be our slope. So we're going to have Y is equal to 10X, or my total cost is equal to $10 per shirt plus 15, my startup fee. All right, so part B says if there is an order worth $345, so my total cost was $345, so let's label that our Y. Is it possible that they ordered 30 shirts? Well, we said X was the number of shirts, so that's going to be our X. So we're going to take these and plug them in to see if this would give me a true solution. So we're going to have 345. Sorry, guys. So 345 is equal to $10, and instead of times X, it becomes times 30 plus 15. So I'll have 345 is equal to 10 times 30 gives me 300 plus 15. And we'll have 345 is equal to 300 plus 15 gives me 315. Well, 345 does not equal 315, so those are not true. Okay, so this is false. So this is not possible. All right. And then last but not least, letter C says give a reasonable domain for this situation. Remember, the domain is our x's. Okay, so our x's were the number of shirts. So this problem is about the number of shirts. So I want to know what is possible for number of shirts. If I'm buying these t-shirts, I could have all kinds of positive numbers of t-shirts. I could 5 t-shirts, 8 t-shirts. I could order 1,000 t-shirts if I wanted to. So I could have positive numbers. Okay. The next thing I need to think about is, could I have 0? Could I order 0 shirts? If I'm ordering t-shirts and I order 0 shirts, I haven't really ordered anything, okay? So 0 is not possible. Okay, and then I need to think, could I order negative shirts? Could I order negative 5 shirts? No. Okay, so it's only positive shirts that I can buy. So it's going to be all the x's that are greater than 0 for positive. So then the next question asks, could an input of negative 12 be possible? We just said it's only positive. Okay, so we're going to say no, I can't order negative 12 t-shirts. Alrighty, flip it over to the back. Remember, if you have questions, please make sure you're asking. Number 3 says Richie is draining his pool for the winter. There are 240 gallons of water in the pool, and it drains at a rate of 20 gallons per hour. Write an equation to represent the relationship between the amount of water in the pool and the number of hours the pool has been draining. Write an equation in slope-intercept form to model the situation. Be sure to define your variables. So we're going to let x equal, and we're going to let y equal. Okay, so we're talking about the amount of water in the pool and the hours it's been draining. Anytime we're talking about time, okay, hours, seconds, days, weeks, months, that's always going to be the x. So the x is the number of hours. Okay, and with all those hours, we're talking about how his pool is draining. So y is going to be the number of gallons in the pool. Okay, so now we're going to write an equation. Okay, so if we think about this, there are 240 gallons of water in the pool. So we started with 240, so that's going to be my b value. It is draining at a rate. Guys, rate is like rate of change, slope. Okay, so that's kind of a key word to look for to know that, hey, this is going to be my slope. Okay, also, if it's draining, that means we're losing water. So that means my slope is going to be negative 20. So now we're going to write our equation. We'll have the number of gallons in the pool is equal to draining 20 gallons per hour per x. We started with 240. All right. So part B says you check the pool and it has 160 gallons of water in it. How long has it been draining? Okay, so it says 160 gallons of water. That matches with my y, which was the number of gallons. So we know that we're going to plug this in for y. So instead of y, it's going to be 160 is equal to negative 20x plus 240. Okay, so we're going to solve for x. We're going to subtract the 240 over. That'll give us negative 80 is equal to negative 20x. Divide out the negative 20. Write this over here because I ran out of room. And I'll get x is equal to negative 80 divided by negative 20 gives me 4. So my answer isn't just x equals 4 because I have a word problem, so I need to write a nice sentence to go with it. Okay, so we're going to say after 4 hours, there is 160 gallons of water in the pool. Alrighty. And then part C says give a reasonable domain for the situation. Remember, our domain is our x's. Okay, so I want to know how long does this pool drain? Okay, well, it can be draining for 0 hours, so we know it can start for 0 hours. But how long does it drain? Because I know the x's is the number of hours it's draining. So I need to know how long does it drain. Okay, well, it's going to drain until I'm out of water, right? So it's going to drain until my y is 0. So in order to find that, I have to plug in a 0 for my y. So we're going to have 0 is equal to negative, negative 20x. I wrote a 12. Negative 20x plus 240. And now I have to solve for x Okay, so I want to know how long or how many hours it took for the pool to have zero gallons of milk. Wow. This is what happens when you record a video too late. I started saying milk. Okay, so we're going to just subtract the 240 over. 0 minus 240 gives me negative 240 is equal to negative 20x. Divide out the negative 20. And I'll get x is equal to 12. So it took 12 hours for the pool to be out of water. So my domain, okay, is going to be from 0 to 12. So we're going to say from 0 is less than or equal to x, which is less than or equal to 12, because that's whenever it was out of water. So if I would graph this, it would go from 0 to 12. And then on the next one, it says give a reasonable range. Remember, ranges are y. If we look up here, y was the number of gallons. Well, we know we started with 240 gallons and it went to 0 because we drained the pool. So it's going to be 0 is less than or equal to y is less than or equal to 240. All right. Number 4 says graph the following function and state the slope and the y-intercept. Okay, so our slope here is a negative 2. And our y-intercept is 0, 1. So we're going to start with the y-intercept at 0, 1. My slope was negative 2, so I'm going to go down 2 and over 1. Down 2 and over 1. Oops, down 2 and over 1. Alrighty. The next part of that says describe the transformations when compared to the parent function. Okay, so we notice that my new function is going down. Okay, we also notice that our slope is negative up here. Okay, so that means the first thing we have is it's been reflected over the x-axis. The next one is that our slope is 2. Since it's a whole number, okay, we know that it has been vertically stretched by a factor of 2. And then the last thing we notice is its y-intercept is 1. Instead of going through at 0, it goes through at 1. So that means it's been translated up 1 unit. Alrighty. Oops. And last but not least, it says write the equation of the vertical line that goes through the point 3, negative 8. So remember, vertical line, that's our VUX, okay? And our point is XY. So that means we see an X here, we're gonna want the X portion. So it's gonna be X is equal to 3. And that's it. All right, if you have any questions, please make sure you're asking. If not, you can move on to your assignment.